Hello guys, and welcome back to Engineering Hack, where we try to solve engineering problems in a way that's hopefully easy to understand. Today we're doing the same problem as before, but this time different approach, right? So the problem is still the load of the hoist, three forces. We're required to determine the magnitude of force P and also the corresponding magnitude of resultant, assuming that the result is going to be vertical, because that's what the problem asks us to do. So last time we decomposed the forces. This time what we're going to do is create the force triangle, right? So I'm going to just write these down here. This is alpha is 40, so this is 40 degrees. 200, this is alpha, so this is also 40 degrees. This is the 401, this is the 201, and I'm just going to grab these and take them with me. Oops, not what I want. And this is what I want. I want to cut this, okay. So this is what we did last time, result and all. And now we're going to do the force triangle, right? So what I want to do is, let me paste this twice so that we don't lose our reference. And what I'm going to do is I'm going to take this 400 here, and I'm going to put it down here. And I'm going to get the resultant of these two forces, which is this green line here. Okay, and with that, I just created a new triangle, obviously. This is the force triangle that we've been using for a while. This is my 400 over here. That's my 200 over there. We have two 40-degree angles. So what do we have here? Inside this triangle, I have this angle here, which I'm going to call gamma. And then we have this angle here. This angle here, I can find out, because I know this is 40 already. Okay, no, this is 40. And then I can find out this other angle here by closing this off and visualizing this other triangle in here, right? So I can see there's another triangle right here. Okay, and what does that triangle look like? Well, it has 40 degrees over here, it has 90 degrees over here, and then it has the angle we're trying to find over there. Okay, so that angle is going to be 180 total of the triangle minus 40 minus the 90, and that gives me 50 degrees. So if that's 50, okay, and this is 40, then this angle here, this total angle here is 90, right? If it's 90, then it's a right triangle, right? If it's a right triangle, then, things become a bit simpler for us. Because now, let me just redo this triangle here. I'm going to have it here, and then I'm going to do as right as I can, like that. And maybe a bit more. What's the best drawing? Okay. All right, so now we know this is a right triangle, and that simplifies things quite a bit, right? Because I have the 400. Brilliant. Okay, so what do we have now? We have a right triangle, so that means that we can use Pythagoras to find out the resultant here. And if you recall, what we're trying to find is really two things. If this is the resultant force here, okay, what we're looking for is the y component of this force and the x component of this force. Okay, both of which I can find as soon as I get that resultant, right? And that resultant is easy to calculate, because the resultant, we're going to call resultant R, is just going to be the square root of 200 squared plus 400 squared, right? And that resultant is, what did I get? 447.21. All right, that's pounds. So far so good, right? Here's the trick though. To be able to decompose this force, I need to know this angle here, which I'm going to call theta. I need to know that angle there. And I don't know that angle. Not as of now anyways. What I do know is this other angle here, which is 40, because I know it makes 40 with the horizontal. And therefore, this blue angle here, which I've called, which I've called gamma. So that gamma there is going to be my theta plus the 40 degrees, right? So what I can do here is I can exploit the triangle that I've created to be able to find gamma. With gamma, I can go ahead and find theta. With theta, I can decompose the forces and find my answers, right? So what do I know about this triangle? It's a right triangle, right? And I know that the sine of gamma, and gamma is this guy here. I might want to do, we go ahead and copy this so we're not losing track of stuff. That we're always with our references in place. Let's not distort a triangle. Come on. All right, I can't not distort it, but I can remove this here so that we are looking at the triangle that we're interested in, right? And we're looking at this guy here. This is a right triangle, so therefore sine of this guy will be my 400 over my resultant. Or if I want to, I can use a tangent, right, which is going to be P, 400 over the 200. It's up to me. It can be whatever. So what I'm saying is the sine of gamma equals 400 divided by the resultant that I found to be 447, was it? Yep, 47.21. Okay, or alternatively, if you want to, you can do the tangent of it, and the tangent of gamma will be the 400 over the 200, which is 2, which is super convenient. Okay, but if you do it this way, what we can do now is then do the arc sine, right? The arc sine of what we're looking for here, which is the 400 over the 421, and that's going to give me gamma, right? Obviously, I can do the same thing here. And if I do that, I get that gamma is 63.43 degrees. Okay, and with that in mind, what I can do now is I can find theta, right? And if I find theta, then I can go ahead and find what is the decomposition of forces, which is what we were trying to find from the start. So what we can do now is, if this is 63.43, then theta is going to be 23.43 degrees, which means that I can come back to this idea here, and now I can, when we draw this, I'm going to copy again, once again. There's only one triangle at a time. I think that makes sense. Okay, so now we have this force here that we know to be 447.21. We have this angle here that we know is 23.43. And basically what we're trying to find out is what is the decomposition of force here on the x-axis, and what is the decomposition of force here on the y-axis, right? And for that, now, super simple, right? And just do, okay, the cosine, let's do sine first. Oh, the cosine, because it's a, right, part A. So the cosine of theta will be equal to my Fy divided by my 447.21. So that's going to give you the y component straight off the bat. My Fy equals, this is 23.43. And therefore my Fy is 410. And over here, changing colors for my B, my sine of 23.43 degrees will be equal to my Fx divided by my 447.21. So therefore my Fx is 100 and they get 177.8 pounds. Brilliant. And if you recall, well, we wanted, oh, I think I flipped these, right? So this is B, and this is A. So what we wanted is find what's P, and P was going to be whatever we needed to counter the X direction. And then the resultant happened to be exactly the same as the Y direction. Okay, so this is going to be my answer for part A. This is going to be my answer for part P. Hopefully these match. So let's go in A177. We go before. A177 matches. then be 410. See if that matches, because we forgot already. Yep, 410. Okay. So, right, so it's another way of doing it. Obviously, the answer should be the same unless we did anything incorrectly. I'm not sure whether you prefer to do it with a force triangle in this case, because you need to visualize more triangles. You need to do a bit more geometry. You need to do Pythagoras here, solve for this guy here. Now, there's nothing fancy, but honestly, I find the decomposition of forces in this case much simpler than using force triangles and trying to identify the angles there and trying to use the composition afterwards. Okay, obviously it's up to you. You can use whatever method you prefer, but I think this is a clear case that, for me anyways, when you do the force decomposition, it's straightforward, straight cut. You can see what's happening. You can see the forces, and then you just look at the resultant. Here it's a bit more abstract. Okay, there's a lot of cases in which the force triangle is better. I think this is when you start going into the realms of these forces and having more forces, then the force triangle starts to get a bit slippery. It's a bit of a slippery slope here. Okay, so hopefully this was useful. If you have any questions, as per usual, just leave them down below in the comment section. If this video was useful, consider giving it a like, and we'll talk soon.